Hello, welcome to Monday again. Welcome to another episode of Bitcoin class with Dr. Satoshi. And what new things we're going to learn today?
Okay, so we're going to continue with some of the other concepts, but I'm going to drill down a little bit further. So I said we're going to continue talking about filters. Now, we've talked about filters and we've talked about masks. Now, I'm going to start giving you some more questions in my normal Socratic annoying way about getting you to think about these things. Now, when we're talking about all of this, I want you to remember what we've done before. So I talked about the creation of network masks, like the transaction masks. How we could actually put an overlay into the transaction that made a sort of, for instance, a hash match against certain aspects of what would be in a transaction.
Okay.
So we can pull out certain fields and check that they match a condition. Now, if you remember what that meant, it meant that we could have a like a opcode type thing and a certain defined length that we put in, and then sort of a defined format that will have to remain the same for our transaction type.
Yeah.
Okay, so we remember how to do that?
It's I mean, many ways, right? XOR is one of the simplest way.
XOR, other ones, yeah. But when we've got that, we can remember we can also now do things like taking a hash of that information. Now, we can put that
stuff.
Yeah, HMAC, other hashes. But if we have a set template and we want that to always remain the same, now is that going to vary in a hash? Not a HMAC, just a standard everyday hash. If we put that information and say this gets fed here in this format, and we pull out a set of information in a particular order, stripping out any of the data you put into a field that we're doing a check on, can you tell me what the hash will always be of that?
A hash for the whole thing? Is that, what do you
mean?
Well,
if we're not making a different version of template, there won't be any changes, will there?
No. So yeah, if the data doesn't change, the hash doesn't change.
Yeah, so, but what if we now pull out all the template from the data and check it? Will it be any different?
No.
Exactly. So what we can also start doing is doing something as simple as even using the low-grade hashes in Bitcoin, like it supports SHA-1. So we could actually do that as a little marker, a checksum. Now, if we put a checksum into a transaction, a particular value field that we have a quick hash check on, which SHA-1 is comparatively fast, what does that mean for both miners, for exchanges, for people running alternative structures like overlay networks, things like this?
You can at least for me, you can check the data has not been tampered with.
That's one thing. You can check that the template is correct, but you can now take that further. If you have a small value like that, you can now start scanning for that small value.
Oh,
if, for instance, there are transactions going around the network, you can just put a small, simple match into the stream that says, if I get this particular template format, which has that particular hash, then off I go and check.
Okay, so it's almost usually for filtering purpose, like a tag it, like an ID.
Yeah.
You can.
Hmm. So how do you differentiate UDP and TCP in a network stream?
I think there's some header. They have some different field.
There's a slightly different field. And um, if you have that field set correctly, uh, you can have very fast layer 2.5 switches that will pull the information out and send it to different locations based on things like IP address, um, information within the field structure, etc.
Mm-hmm. So
So
you are saying similar things can happen in a transaction. If you treat like an IP packet, then you can have
yeah,
different
remember,
field.
if you're matching set values, that's quick.
Mm-hmm.
You're not doing a hash when you're checking for something.
No.
Now, you might want to pull it out and then check it. And that's
Mm-hmm.
going to take time because you still need to validate that the transaction's real.
Mm-hmm.
Because even if you have uh, a string of numbers, someone could decide to be a bit of a wanker and put that into their transaction um, just to cause you problems.
Okay. So it's like a
And they
false
could make
positive, right?
valid transactions.
Mm-hmm.
Yeah, exactly. People could like do an op return or push data or something like that containing that value just to be a bit wanky and
Mm-hmm.
give you extra work. In this world, that's not something particularly out there. But then you do a quick check, even if it's a SHA-1. Having to get all the extra information to breach that costs money and time and economic effort.
Mm-hmm.
So, um, so that's our first layer of filtering.
Mm-hmm.
So we can now start basically doing protocol headers, not the way that we had it in TCP per se, but now we can do other such things. I mean, you can filter in sort of address formats and other things as well, but you can also do template formats.
Template format. Or what do you mean?
I mean, I've been talking about not just using Bitcoin as Bitcoin, but creating all sorts of other things in it.
Mm-hmm.
Template structures that enable you to pay to other template structures.
Okay.
I covered in the past using things like XOR, remember, to have a
Mm-hmm.
defined template that says I will pay to this structure that could even have the template in it, if
Mm-hmm.
you remember.
Mm.
Now, I want you to think a little bit further on that one as well. Um, that just as a side thing for you to think about. Do I need to pay to the same template structure?
No.
Exactly. So I can actually have options going pay to the same template structure or pay to one of these other ones.
Mm-hmm. In the output, right? That's what you.
Yeah,
Mm-hmm.
correct. And that could even be like a binary tree type structure where I have many different possible template structures,
Mm-hmm.
and even all sorts of complicated additions of things and fun stuff like that. And all that can be done in script. So what I want you to now think about is how do I, if I'm not a miner, I want to just pull certain things out, or even if I'm a miner, how do I isolate things quickly for different fee structures? How do I give someone a discount for having things together versus making it more complex?
So I think one thing you can have is you just mentioned, right? Kind of like almost like a particle headers, but on top of
Mm-hmm.
a real layer two, you
Mm.
can put different field and then different values.
Yep.
I don't know. Let's say you put a first 32 bytes, 32 bits or something. If
Mm-hmm.
it's all zero, you know it's
Mm-hmm.
from I don't know, trash. If it's all one, it's from I don't know, money button or something. Is
Yeah,
that
I
something?
mean, and so companies can even start doing this to differentiate their own versions of like marked Bitcoin, not even to not be Bitcoin, but to say that it comes from Money Button and to be able to filter Money Button transactions quickly, to be able
Mm-hmm.
to say that you're from CentB and to filter out CentB transactions quickly.
Mm-hmm.
whether it's a transaction to and from a cent B to another one, or alternatively to a money button or something like this, you want to then be able to only filter those on your device, and you don't want
Okay.
anything that's not correct. So even if you've got a stream of information to your device that was definitively set to you, maybe you have different transactions like you do in TCP that your stack can now start filtering.
Mm-hmm. So two questions. First, is it going to be like a more standardized? Let's say IP packet. Now you build TCP or UDP, but these are two
Um,
like almost the dominant protocols. Do you imagine this
well,
going to be standardized into a few? Everybody is going to follow the rule, or they each can do their own thing? Or?
I would love people to do that. I mean, but then we need something like an RFC process,
Uh-huh.
which for all these people who run around going centralized, the IEEE is not actually centralized. It has a loose group of sort of policy wonks who put all sorts of wacky stuff in, and that's what decentralized really is. It still goes to a central sort of mailing thing, and then it goes out to the world, and there's no problem with that. And if you want to make Scrypt protocol
Mm-hmm.
on the internet right now that distributed Bitcoin through some TCP something, there's nothing stopping you doing that. And you
Mm-hmm.
could actually write your RFC, and whether anyone ever used it is another question.
Mm-hmm.
But if it was good and useful, then you would find that you end up with people using your protocol.
I see. Okay, it's like what we already have a TSC, right? So like, kind of like a IEEE, and they're already
Mm,
putting out a lot of standards proposals out there for
yep.
anybody who you can also comment, review anybody.
Yeah. So the thing I'd think about is how do we get people to do this? So, I mean, um, I would love to see that happen. I'd love to see people start actively putting their protocols under some sort of header. I mean, the concept of where uh, sort of the Bitcoin um, Foundation originally put things out was very different to what it ended up becoming. It wasn't about changing the Bitcoin protocol. It was meant to be how do we build things on top of Bitcoin. For
Mm-hmm.
some reason, that ended up being completely different, but don't
Mm-hmm.
ask me.
Mm-hmm.
Um, it's yeah, just insane. But anyway.
Mm-hmm.
Um, so
Just I think that's my first question. The second, I think you already answered a little bit. Basically, how do
mhm.
you prevent other people from manipulating the, for example, if it's all zero is from Twitch, but what's preventing some just attacker he just put a field at all zero and then try to confuse Twitch data?
Well, if you've actually got a transaction that includes something like a SHA-1 hash,
Okay, so you,
then that's going to be very difficult for them to do. I mean, you
okay,
can. I mean,
you can.
if you're that panicky, you could put SHA-256 or
Mm-hmm,
RIPE or one of the other hashing
mm-hmm,
algorithms in there. But
okay.
just doing a SHA-1 over that would do it. On top of that, you
Mm-hmm,
could do other format checks and things.
okay.
Doesn't need to just be the one. So when you're setting this up, you can structure it so that there can be simple checks as well as sort of pulling out checks on just the SHA process. So without even doing a check for whether it's a valid hash, you don't even need to hash it. You know why?
Um, um, no, is that possible even? Like, how do you
Well,
know if it's a match? You
okay.
don't have.
So what happens if the miners receive a transaction and it's not valid? So the hash doesn't work out if you've got a check that says
Mhm.
hash this particular thing and part of the transaction.
Oh, you failed. You will not be in the block.
You fail.
Mm.
So if you have a certain set of opcodes,
I see.
say the
Okay.
one for SHA-256 or
Mm-hmm.
SHA-1, and that is in the transaction, and then the hash of
Okay.
the mask is in the transaction,
Mm-hmm.
do you need to check it yourself?
No. Mm.
So if it comes out of a block, you know that it's been checked.
Mm-hmm. Okay. So
I
you kind
mean, and
of
lots of other people will get that.
outsource it to
Sorry,
miners.
keep going.
They already checked, so you don't have to check.
Yeah.
Okay.
Mm-hmm. Exactly. So because you're actually doing this as part of that structure, then um, this whole we have to check everything that's happening everywhere stuff, it gets a bit insane. If you think about it, um, what happens to miners who don't properly check transactions?
So they got orphaned, right? So,
Yeah, they get off and they lose money.
mm-hmm.
So we've seen that plenty of times, even in Bitcoin and BTC and everything else history. A number of years ago, for instance, um, Roger Ver and Bitcoin.com
Mm-hmm.
created a block that was
Mm-hmm.
outside of what miners accepted.
Mm-hmm.
And everyone ran round happily going, ha ha, Roger's lost money and all that sort of stuff. But
Mm-hmm.
it was a stunt to make it larger anyway. So, but the whole point being that if you don't follow the rules the way that they're sort of on the network at the time, that an individual group of miners are looking at, then that group of miners will reject you.
Mm-hmm.
So Um, the concept here to try and understand is you can have simple machines that do simple exchanges, but you don't need to have a um, large sort of grouping of checks and validations because you're paying someone to do it.
Mm-hmm.
And it's not just you're paying someone. The difference with Bitcoin and why you can trust it is you're paying someone to look at someone who's looking at someone who's looking at someone who's doing the
Mm-hmm.
work.
Mm-hmm.
That's the nature of how miners are.
Mm-hmm.
Because what happens when you don't do this correctly? Well, one of the miners will figure out that he can make a little bit more money by orphaning this guy, pointing out that this is an invalid block. Um, we've seen that many times in the past, as I noted, with spy mining and other such things where people tried to build blocks too quick and ended up being rejected and orphaned and losing money. And yes, some people started building on them. And guess what? They lost money. And that's the whole
Mm-hmm.
point here. So
Mm-hmm.
the key aspect of all this is it doesn't work unless you actually follow the rules and do the checks as a miner.
Mm-hmm.
And everyone else running nodes can also validate that and complain and jump up and down and say, I don't like what this guy's doing.
Mm-hmm.
So it's all public. That's the wonderful thing with Bitcoin not being encrypted. It's a public network that everyone can view. And ironically, there's no way to have it both ways. It can either be an unencrypted public network, or it can be a private network that nobody gets to monitor.
Mm-hmm.
Can you see why?
Oh, if either public or not, that's that's
Exactly.
one of the binary. I mean, you always have a false dichotomy, but this is like a true dichotomy.
Yeah. So, I mean, um, but there's other benefits, of course, to this, in that being clear text with authenticity protected because of the SHA algorithms, etc., it doesn't have the confidentiality aspects of transactions in the same way. That's done differently, as we've discussed before as well, but it does enable you to firewall identity. So that's how you get your confidentiality. Now, integrity is protected. The
Mm-hmm.
hashes protect integrity, that no one can change even a bit of information in a transaction or any of that stuff.
Mm-hmm.
So this means you can trust the information in a block. You
Yes.
can trust if that is there, if it says this source, this destination, this template, when you build a template, that you know that it's real. Not because you've even checked it, but because the network has checked it and validated it. So even if you're taking very simple machines such as Internet of Things, you can start building sort of controls around that allow you to filter out information that may be sent to different networks, etc. Different transaction types could be filtered at a router, for instance, and then broadcast to all these devices all over the place, and only certain ones picked up. And even if they can't validate the signature, they can trust the transaction because other people have validated it for them. So one of the aspects of not needing to even just to be a monitoring system and not even have an IP address or anything like that is you can send like covert information, covert channel type stuff to control these devices that an attacker can't do anything with. He can't spoof because how do you spoof it? I mean, unless you've compromised the key. And compromising the key is compromising the key, whether it's on your machine or not. But here's an aspect of this people don't think about. I don't even need to have the key on the end device, the Internet of Things device.
Yeah, we talked about it last time.
I can, yeah. So I can filter this information. When I'm setting my filters up, I can say, these are my my keys that I'm watching for. And if I know where they are, even with something like TCP dump or Cisco router filters or IPS filters or layer 2 forwarding filters, I can now pull this bit of information out from this part of a packet. And I can make a protocol that forwards these things. So I could even embed a little bit of TCP gumph at the beginning. I mean, have you played with Netcat or any of these things before?
Netcat and TCP dump. Yeah.
Yeah. So tell me, when you're doing Netcat, what is it that you're doing?
Oh, it's pretty much like you are like a filtering based on different patterns. It's either which port, which coming IP, or is it TCP IP, no TCP or UDP or whatever. Basically, you are like doing kind of like a grab. Yeah.
So one way I put it is it's a very simple way of teaching people how to create sockets without even having them really code. So everything you can do with developing sockets in something as horrible as Python or something far better for sockets like C, C++. And I know people are going to sort of just with me for that one, but honestly, Python is horrible when it comes to building sockets.
I mean, we don't have to get into like a language like a religious course, but anyway, it's always Python or but people will argue, right? Python, in Python you only take one line, but if you C++, you take maybe like, I don't know, 50 lines just to start some
exactly,
some server or some port. But anyway, that's.
But even if you're doing quick, nasty testing, Netcat will allow you to start building these sort of things, even build simple servers. They used to teach people how to do quick, nasty, like web servers using Netcat because all the headers are the same. You've got a standard if you see this, if you see that, and you can actually just script it up in Linux pretty quickly and build your own horrible web server. I'll admit that it's horrible, but if you think about this, you can start doing all of that with TCP. So do you remember when you're talking about HTML and HTTP transactions calling a web server, can you tell me what actually occurs?
Oh, you just have it's always client server, right? You have a server always listening, You go to the socket at some port number, you have some requests, and then server process it and send you back the HTML and JavaScript, whatnot, back to your browser, and then you just render everything.
So ironically, most of the original sort of SMTP, POP3, HTML, Gopher, all these things developed from Telnet.
Telnet, yeah. Even when you do the whatever TCP time, sometimes you want to verify, right? Some server is up now. You also use Telnet. I mean, it's like too old. I don't know if people use newer stuff.
I mean, you can get newer things if you want to be able to do TLS or SSL, and that will allow you to do the key exchanges without having to get involved. And then you can type in like Telnet, and then you can do your get functions, etc. Put, post, all that fun stuff, call to the server. Now, the same sort of thing could be done in a very simple socket for sending Bitcoin transactions to particular machines. Either they could be pulled or filtered or forwarded by servers or other things like that. So that's another way we could even look at this. And that allows us to send information between things that can be controlled. But going back to what we were talking about before, so we want to be able to even filter information. So tell me a few ways we might be able to do that. If we've got a block, if we've got other things, how do we look quickly for information we want to filter?
Oh, you can either you can filter at the easiest layer, the network layer. You can look at all the let's say TCP packets, and then just using some existing tools to look for some pattern, maybe some field, let's say fifth byte, whatever. You can say, oh, it has to be all FF or something.
Yep. Yeah. On top of that, if we wanted to make it even more complex, we can start doing things like cuckoo filters and other stuff things, but we don't even need to go that far. So the irony in people thinking about this is they just keep thinking Bitcoin transaction. But you've got to start thinking, what else can I do with a Bitcoin transaction? I mean, in the early days of the internet, there was this IP connection thing. And then they got a bit smarter and added TCP, UDP, RSP, reliable transport protocol, all that sort of funky stuff, and then sub things on that. Now, if we want to build applications, we need to start thinking about how we build things into Bitcoin transactions, not thinking that you need to run a node. So going back a little bit further in history, that no one seems to remember because it got stripped out and never put back in. I keep mentioning IP to IP, which is one of the fundamental aspects of Bitcoin that used to be there. So if I communicate to your machine and you have a particular Bitcoin client or server even, what can you now do?
I mean, the first version, you can do payment, right? Send payment back peer-to-peer.
You can send payments, but in the original client, the bit that it would do would be negotiate keys, etc. I mean, it wasn't too much sort of deep thought in it. It was just, I can connect to you, I can ask you for your key, you can give me a key, I can now communicate with you. Now, equally, I can put, what else can I do?
I mean, now we have if I know your key, we can also do all kind of this like a 42 style, like we can do key exchange and then do communication, have a common secret, shared key.
We can, but what if, before I even get to that, one of the things we've been mentioning is filtering. So if I
Okay.
send you a particular type of transaction, maybe you want to react in different ways.
Mm-hmm.
Uh, Start thinking more complex than the original Bitcoin client.
Mm.
I mean, that ugly thing was because my UI skills are
Mm-hmm. Sub.
non-existent.
Okay.
I
Suboptimal.
mean,
Anyway. Okay.
yes, and you'd think that someone would update it and all this time. I mean, um, oh well. I guess some people like ugly. Um,
Mm-hmm. Just ask
uh,
BTC guys. Yeah, they like
exactly.
always command line, whatever. Okay. So you are
Oh,
saying you can. Why would like even peer-to-peer case you're saying this? Even in that case,
mhm.
you can Alice and Bob. They can use different types of transactions. And
Um, think of it in the future. Maybe you can start different Bitcoin clients. They can negotiate with each other. What do they take? So um, now, if we're talking about templates and we're talking about building things in Bitcoin, including different types of asset class, different types of tokenized goods, different types of central bank digital currency.
mm-hmm.
Okay, so think about what that now means.
Okay, is it? I
If
think
I
about the.
make a if I make a Bitcoin client, could I make it extensible? Could I allow you to add options to say what you will and won't accept?
It's like yeah, nowadays servers, right? When you client first connect, you can ask
Hmm,
what kind of things does it do. Support like
yeah.
I don't know, HTTPS or TLS or whatever your capability it is.
hmm So imagine in the future, I could say I accept native Bitcoin,
Uh-huh.
USD, pounds,
Okay.
euros, and yen.
Mm-hmm.
Or and someone else might say I accept USD and pounds. Someone else
Mm-hmm.
might say I only accept euros.
Okay.
And when we have tokenized goods and services, all of that's going to now make communications a little bit easier. Now, one of the things I was saying is we want to try and make it simpler for people who are using each of these sort of tokenized things, game tokens, etc., not to try and send them to the wrong people.
Mm-hmm.
Although you can manually create a Bitcoin transaction and sign it so that it goes somewhere that isn't recognized by Game or by a particular like central bank currency token or something like this. Do you want to?
No, it's like it's like we in principle in theory we can do this Zoom, but me writing some raw IP package and send you, you encode your screen share
Hmm.
back to me, but it's just it's like a low level plumbing, so we
Hmm.
only care about the
On top of
application.
that, I don't want to destroy things generally either. I mean, for instance, why would I want to destroy a £10 note?
Mm-hmm.
Although some people do this and they set the money on fire.
Mm-hmm.
The differential here is
Max
that
Kaiser,
the central bank will now, yeah, the
yeah, they
central
tell
bank
it.
will be able to monitor
Mm-hmm.
this.
Mm-hmm.
So if you intentionally destroy your money, all you're doing is giving it back to the government. I don't want my £10 anymore. You have it, government. Uh, I mean, because they'll see £10 gone, burnt.
Mm-hmm.
And all they do is say, here's my proof of reissue, and yay. I mean,
Mm-hmm.
so it's not like you're burning the money anymore. It's like you're burning the money and sending proof of the burn back to the government with
Mm-hmm.
the cost of a new note so that
Mm-hmm.
the government can just reissue it and replace it instantly. Except the difference
Mm-hmm.
is you don't get it this time. The government now has it.
Mm-hmm.
They have your shiny new £10 note that you've
Mm-hmm.
just thrown away and said, I want to donate this money to the government because instead of paying tax with it, I'm going to just give them 100 cents in the dollar. Yay.
Mm-hmm. Okay.
becomes a rather
Yes.
stupid objective. But you
Mm-hmm.
can. You have that freedom. See,
Mm-hmm.
Bitcoin gives you the
Mm-hmm.
freedom to be stupid as well.
Mm-hmm. Okay. You can, yeah, it's like not like a BTC, like a Bitcoin can fix this, can fix everything. So,
Correct. So if we start thinking about that for a moment, uh, when we're building applications in the future, what we're going to want to do is choose who we want to talk to and not. Now, if I try and go into a restaurant and they don't take Amex, what
mm-hmm.
happens?
Oh, you cannot eat
Can I
there.
try? I mean,
Mm-hmm.
yeah, I mean, if I want to pay with that thing, then it's not going to be accepted.
Mm-hmm.
Now, equally, if I have a wallet that supports US dollar central bank digital currency in the future, and I'm here in Britain, and the people don't accept US dollars, then guess what? It's not going to work. So why would I want to try and send that money and communicate and exchange if it's not
Mm-hmm.
going to be accepted?
Mm-hmm.
So I can filter that out as well, if you
Okay,
see what I'm
I
saying.
see. Mm-hmm. Yeah, more secure. You don't accidentally burn some USD
Hmm,
in London or something.
yeah. And this is an important thing that I think people need to get to understand. Too much of the BTC mentality and Ethereum mentalities out there, which is um, sort of developers are gods, and if you're not a developer, then you're stupid, so go away.
Mm-hmm.
We have to remember that the average user does not want to ever see the back end of Bitcoin. They don't care.
Mm-hmm. Mm-hmm.
If we want this to really work, do you want to have to watch traffic using TCP dump?
No,
Do you want to
no.
know how?
Mm-hmm.
Most people don't care. Just because
Mm-hmm.
you can do it doesn't mean you even want to do it. I mean, I know how to communicate with web servers directly. I used to do things in my classes when I was teaching, having people actually connect and send email or pull down their email from POP, um,
Mm-hmm.
validate it, calculate how to do MIME and other stupid things like this. And even write, one of the exercises I had in the past was download this file, um, extract it, save it, extract the MIME
Mm-hmm.
information, convert MIME back into something that's readable, and yada, yada, yada. Now, that might be interesting from a developer's point of view, but you don't, even as a developer, want to do that generally. When I
Mm-hmm.
open up my mail client, I don't want to have to go in there and manually um, sort of reconfigure every time to get these things. So I want to make it simple. And
Mm-hmm.
if we're going to have Bitcoin really go out to the masses, we need to make it simple.
Mm-hmm.
So we need to put all these error checks in. We need to start building different protocols that people will have. Now, you were asking before, um, like, how do we get this going? Well, people will build their own, but if they want to be interoperable, and I'm old enough to remember Interop, back in the early to mid 90s, there was a sort of global conference called Interop,
Mm-hmm.
and all us silly bodgies would go along and talk about trying to connect Bay Network machines to Cisco machines to horrible other things. Um, I don't know if anyone even remembers who Bay Networks are, but
Mm-hmm. No,
do you actually remember who? No, no,
no.
I don't know.
That's
I think
no.
that they were bigger than Cisco at one stage.
What's the name again?
Bay Networks.
No, it's probably gone for a long time.
So Cisco, of course, you can see why they're called Cisco if you really think about it,
San
because they're from
Francisco.
San.
Even the
So
bridge, the logo is a Golden
yeah,
Gate Bridge. So
so what do they call the bay? I just sort of, that was
mm,
stupid the way I said that. I mean, San Francisco Bay, they just call the bay, right?
the Bay Area, yeah.
Yeah, so Bay Networks,
Bennett.
like Cisco, started in that area, and they just called themselves Bay Networks.
Mm-hmm.
They became a company that you might remember the name of, or got sort of semi-bought out and a whole lot of mergers and all the normal Silicon Valley stuff. They became Nortel,
Oh, not tell. Oh, okay. That's good.
and
Good history.
and,
Okay.
and they even sort of, yeah, they lost out as well. But
Mm,
um, all this in the past, like with 3Com and other networking companies,
mm,
people got together and they all had their own things they wanted to push and they all had differences, but they also tried to become interoperable. So
mm,
if we want people using Bitcoin, then yes, you may have this difference in protocol and to this person, but if we want to exchange goods and services, then we want to be able to do that as simply as possible. If I
mm,
want a wallet that will accept NFTs or
mm,
tokenized goods or asset ownership certificates or anything like this, I want to be able to make sure I can do it correctly.
mm,
I want to make sure that I'm getting an exchange for it. So, as an example, one of the things I did a patent on years ago was like a secure atomic swap, even
mm,
between different protocols, etc. Now, if I'm doing that, then I would want to make sure that you're running a protocol that allows me to do that, wouldn't I?
mm,
Otherwise, I send you something and it goes nowhere, and we
mm,
don't end up actually doing an exchange.
mm. Yeah.
So,
It.
so um, when we're thinking about all of this, what we need to start thinking about is not just how I build in script, but how I build on servers as well. Whether it's something um, for old-fashioned old people like me, like in C++,
Mm,
or whether you're doing sort of JSON and Pythony type things and WebSockets, etc.
mm,
Even building in WebSockets, you can send information such as transactions, etc. That can be validated to be in certain formats, and that just simplifies all of the problems. Because, for instance, if you don't want to take a malformed transaction, that's just making your life a lot easier if you're talking about error handling, cleaning up memory, etc., in your code.
mm,
So um, now the other question you're asking about is how do we get people to do this? Well,
mm,
that's part of why we have these groups where people get together and have hackathons and brainstorm.
mm,
Not just showing off whose code is better and all that sort of stuff. It should also be trying to get together and formulate how we can do this correctly, how we can actually put the concepts down so that other people agree with.
mm. So you kind of do you expect this to I don't know, like building different layers, almost like you're building a different network stack like OSI, like a 7 layers, but on top of Bitcoin? Is that
Um,
something?
yes, I mean, we can do multiple layers of that, including fast direct communications, as well as within TCP. And of course, within TCP allows us to have an existing port. Someone could go out there and write an RFC, put out a defined structure. The transaction itself and some other header information could be built into something that gets sent. Um, there could be payment channels or not, depending on what sort of thing it is. Um,
Okay, so it
Register a
could,
port, get it formally
mhm,
out there, as etc.
mhm. So it could be on existing TCP/IP stack. It could also be it's a brand
Hmm.
new stack on just based on Bitcoin native
Mm,
transaction. Okay.
yeah. So even looking at email, um, in the past, everyone connected to SMTP and POP. Well, not everyone, but then there are other things like MAPI. There are other newer forms of email client. IMAP replaced POP. IMAP SSL, et cetera, et cetera. Google's got a whole lot of wacky protocols that I never really learnt. So even if you look at streaming web, etc., look at all the things that Facebook APIs now build, and you can I mean, one thing we could even start doing is building our own APIs to allow this to happen. People don't even need to really care that they're doing Bitcoin. I've said many times that it can be plumbing. The majority of people on Earth won't care. They're not going to get into some sort of cultural trolling. And I mean, when was the last time you saw someone running around going, I use the Singapore dollar, you use a Canadian dollar, I'm better than you?
No. Maybe long time ago.
No,
I don't remember. Never.
Not that I know of. I mean, I've never known people running around going, I'm a supporter of. I mean, you get people with the dollar, but that's really an American thing. That's not about the dollar. It's about being American. I mean, they don't sort of, yeah. I'm sure there's probably some wacky group out there in deep dark web or something like that is, but I don't know about it. But
like too French. Okay.
Yeah, people don't really care. They don't want to know. I mean, they don't want to sit there going all this sort of religious Bitcoiny type stuff. They want to be able to get money, buy goods, buy services, because the pathology that people aren't getting, that it's not money that is the important thing, it's goods and services. The economy isn't richer because there's more money. The economy is richer because there are more goods and services.
Yeah, otherwise you can just print the money. Everybody is rich.
Yeah,
on paper.
Zimbabwe.
On paper, yeah. Everybody's a trillionaire.
Republic.
Everybody's trillionaire.
Yeah.
But,
although that seems to be the way it's working out with these NFT things and all the rest. We're all going to be super rich, and we're all never going to actually spend our money because we're all going to just sit there imagining how much it's worth and what we could eventually buy when we don't spend it.
Yeah, it's I think a meme is saying on Twitter saying in the old days, I mean, yeah, we can think about, don't worry about too much accuracy, but they use the YAP stones for money, right? But now we use like a JPEG stones for money.
Yeah, well, I mean, I hate that YAP stone story.
Yeah, I know. It's debunked, yeah. But anyway, it's kind of funny to see the irony.
I've tried to do my, I mean, that's the irony of that being a Bitcoin story. The irony is that it was Lloyd's Bank who really invented the big YAP stones. They weren't the islanders. It was Lloyd's Bank to deflate the economy and basically buy up land. So, and if you think about that for a moment, all these Bitcoiners from the past are embracing this story that is really about currency devaluation and the bank taking over a culture. And they're sitting there going, evil banks. Well, and then you're embracing a story of YAP stones that are exactly the opposite of what you want. But
now they're using FD stones.
So, I mean, what you're doing is in Scrypt is great, but and after I get a few things out of the way this year, I mean, this is an area I want to start focusing on. We need to start thinking about sort of exchange protocols, APIs, etc. Because if we can make that simple for people to do, the equivalent of building web services, then there's a whole new layer of what can be built. So right now you build with Bitcoin, but what if we could build APIs that enable you to integrate Bitcoin?
Okay.
What if in your web server, rather than running a Bitcoin client behind there, because that was the simplest way to do it originally, what if you could build that logic into your web server?
Like
And
what
remember, I said,
examples?
um, well, remember I said you don't need to actually hold the keys on your web server, your merchant gateway. You can receive the knowledge of the public keys. You can even calculate public keys. Like remember the different things with how to do updates using 42s and other
42
derivative
derived
methods.
keys.
We can do a whole pile of derived keys, and the web server can derive those keys without ever having sort of direct knowledge of what the private key is.
So what would be
So it
one
can
like
say, pay me here.
payment? Okay.
So I could be the head office, you could be the branch office. I could give you today's base key, and now you can calculate a series of subkeys, and you can know about payment to those and validate them. And in doing that, I get paid directly, not you. So, for instance, you can construct all these things to get paid. Now, the argument is, oh, but what about change? But what about change? I mean, if I'm like you're getting paid in the branch office, you're not the one giving change. The person creating change can be the one paying you, can't they?
Yeah, they have
So,
the change output, return it to themselves. Okay.
yeah. So we've got to start rethinking how we do some of these sort of processes because they're a little bit different to how they were in the past. A little bit different of having money in the till. I don't have the money in the till anymore. The money goes directly to head office. The money can directly be paid in such a way that I have a valid receipt of what's been exchanged. Now, that's also more important in that if I'm starting to set up like the equivalent of a web payment channel, then I'm going to be able to structure how money gets paid in different parts of the organization. Not just one payment, but I can say these are the payment addresses. This one's my tax. This one's goes to my suppliers. This one goes to a factoring agency where I've got reverse factoring from my supplier. This one, all sorts of funky things. And the person paying you doesn't need to know anything about it. They just need to do the exchange of addresses and exchange of a payment amount. And people started trying to do that in the early days of Bitcoin. If you remember, so the payment requests.
There's,
So that can all happen.
there's even an error code, right, in the HTTP request.
Yep.
That's kind of like a missing one. Okay.
Yep. So not going to do much more tonight because we're coming to the end. But I want you to start thinking about how we can extend all of this. Because not just in script now, but think about the surrounding systems, the APIs, the sort of microservices that we can build into things, including modern web servers, applications, etc., that will just embed Bitcoin natively. Now, you can't do that with things like Lightning or all this other junk, but with Bitcoin, we can now build this single native network that we don't need to worry about trusting because if as it gets bigger, it gets more trust. Think about it for a moment. I mean, if we have one global Bitcoin network, then every sub-protocol is instantly trusted. Whereas if you have 50,000 different coin things, then you have to have, I validate that one, but I'm receiving this one. I need to go and check whether that's still valid. And yeah, lots of fun.
Yeah, it's similar with I haven't been through, but you have been talking about earlier. They have a lot of alternative protocols to TCP/IP, but some eventually they just gone. But probably take a long
Because
time.
people,
right? That's what
it
we're
will take
seeing.
a while, but when it happens, I mean, it took years for IPX, .NET, IBM's silly protocol, all those other things to disappear, but they're gone. I mean, it's pretty hard to find IPX on a network anymore.
No, I think most people even never heard about this. Yeah.
I know, but it's one of the more common ones.
Okay, that's good. It's almost will be like hopefully Ethereum will be like IPX. Maybe in the future, people never even heard about it. Yeah, we'll see.
What's this Ethereum thing?
Okay, I don't know what you're talking about. Yeah. Okay, we'll see. But that probably takes some time. Yeah,
No
the
problem.
sooner the better. Okay.
Alrighty.
Okay, sounds
Alright.
good. And talk to you soon. Okay, enjoy the rest of the evening. Okay.
You too. Catch you later.
See you.
Bye.
Okay, catch you. Bye-bye.